Graphing Guided Notes. As you watch, please remember that you have the ability to pause, go back and rewatch, and take notes as you go. Our learning target for this video: I can make, use, and interpret different types of graphs. There are several ways data can be represented visually in charts or graphs. We are going to primarily focus on 3 different types of graphs or charts for this class: pie charts, line graphs, bar graphs. A pie chart is used to show percentages or parts of a whole. This picture here is an example of what a pie chart looks like. Data is represented in pieces of the entire circle or parts of a pie. Examples of when to use this graph could include music tastes in your class population. So 25% of your class likes hip-hop music. Another example, the number of students that play different sports in your school. So 60% of our students at Sandburg play hockey. 20% play basketball, and so on. A line graph is used to show changes over time. Time is a big clue for a line graph. This graph here is an example of a line graph. We plot our data points and then we connect them with a line. Time can include any amount of time, whether it's a second, a minute, a day, a week, a month, a year, a century, or so on. Examples of when you would use a line graph would include how many inches you've grown since you were born, how many books you've read in a month. Again, any type of experiment that uses time or any data set that uses time, we are going to make a line graph. A bar graph is used to compare several different categories. This picture here is an example of a bar graph. Examples of when to use this bar graph could include to show the snack preferences of a student, or the amount of each snack eaten in the cafeteria. In these graphs, you can also do a double bar graph or a double line graph. That is simply when you are comparing 2 sets of data points within the same graph. So notice here, this is an example of a double bar graph. We have one color to represent our class and another color to represent their class. 2 data sets are being compared over the same topic to show the differences. In all of our graph examples, our graphs have had tails. Tails is really important to remember when we talk about graphing, because when you make a graph, your graph will always have tails. You graph with tails. You graph with tails. Graphs include T for title. So our graph example here, our title describes our data set, rainfall during the first 9 days of a month. Our axes, so we have our y-axis and our x-axis, always in this orientation. Y, dry mix, thinking about our variables we learned about in our last video, represent our responding or dependent variable. Our x-axis represents our independent or manipulated variable. Our intervals, notice, are always going to be consistent. So if we go up by 2s on our y-axis, we are always going to go up by 2s. If we count by 1s, we count by 1s. 10s, 20s, it doesn't matter as long as you are consistent in your numbering for your intervals. Labels are going to be placed on both the y-axis and our x-axis. Our labels describe what our numbers or our intervals are here, okay? So our rainfall in millimeters describes what these numbers represent. Without this label here, we don't know if these numbers are talking about rainfall in millimeters, number of puppies, number of cookies. Okay? So we always need to include our labels for both our x-axis and our y-axis. Scale is again talking about these numbers. So if our maximum data point for our rainfall is 12 here, it would make sense that our graphing would end around 12. Here it's ending at 14. It would not make sense to have a graph that we make go all the way up to 100 millimeters of rain, because there's a lot of then wasted space on our graph and a lot of unused numbers. So we want to pay attention to our scale and make sure it accurately reflects whatever data we are showing.